Hello everyone, my name is Manoj Palaswal, and in this video I will discuss about the projectile motion, and this video is helpful for the students who are preparing for JEE and NEET examinations. So before starting the exact projectile motion, first I will discuss about a constant acceleration. Suppose a particle is moving with a constant acceleration or a uniform acceleration, then what will be the path or trajectory of that particle? So there are two possibilities. One, the particle can go in a straight line, and the second one is the particle can go along a parabola. So there are two conditions. When A is constant, then trajectory of the particle can be a straight line or it can be a parabola. Now the question is, when there is a straight line and when there is a parabola. So if the initial velocity of a particle u is 0, then it go in a straight line, and the second condition for a straight line is that the acceleration is parallel to the initial velocity u, or acceleration is anti-parallel to the initial velocity. If these two conditions are there, then the particle will always go in a straight line, and rest of the cases the particle will go in a parabola. For an example, the initial velocity of a particle is given as I cap plus j cap, and the acceleration for that particle is given as 2I cap plus j cap. Then what will be the trajectory of this particle? So the options are here. Suppose A is circle, B is straight line, C is parabola, and D is ellipse. So by observing the acceleration, we can see there is a uniform acceleration or constant acceleration, and it is neither the parallel to the initial velocity nor in anti-parallel. So the path will be a parabola. So by simply observing the options, we can take the right answers. Now suppose a particle is thrown with initial velocity u, and the acceleration is a, then what will be the path of that particle? So there are, whether it go like this, and this one. This is the first, second, third and fourth. So which path is correct? So the second one is correct, because velocity always try to achieve the direction of acceleration. So first is wrong because it will never cross the direction of acceleration, and 3 and 4 are going away from the acceleration, so 3 and 4 are also wrong. The right path for this condition is 2. Now let us start with exact projectile motion. So in projectile motion, suppose we have given a particle which is thrown by a initial velocity u with an angle theta with the horizontal. Suppose this is our x-axis and this is our y-axis. So here we can decide the trajectory, and this will be like this. This is the origin point 0, 0 O, and this is the final destination of the particle. So in this condition we have to calculate different things. One is how much distance it will travel in x direction, that is known as the range of projectile. Second one, what will be the maximum height gained by the particle, and the third is total time of flight. So we will calculate these three things for a projectile motion: range of the particle or range of the projectile, maximum height gained by the particles, and total time of flights. So we can resolve this initial velocity along the x-axis and y-axis. So this is x comma y is the coordinate of a particle at any time t. So we can write u is a ux I cap plus uy j cap, and here the acceleration is always due to gravity, and that is minus g j cap. We can resolve this velocity along the x-axis and y-axis, and we can write this ux is u cos theta I cap, and uy is u sin theta j cap. And ax is 0 because in x direction there is no acceleration, whereas ay is minus gj cap. The gravitational force is working downwards. Now we will calculate the trajectory or path of the particle. So at any time t, we can write x equal to ux into t. That is our first equation, because in x direction it is traveling with velocity ux, and for time t it will travel ux into t. Whereas we can write y is equal to uyt minus half of z t square. Here we have used the second equation of motion. Now from the equation 1, if we put the value of t in equation 2, from here t is x upon ux, so we can rewrite y is equal to uy x upon ux minus half of g x upon ux whole square. Now if we put the value of uy and ux, we will get y is equal to u sin theta x upon u cos theta minus half of g x square upon u square cos square theta. So here u will get cancelled. We will get y equals to x sin theta upon cos theta is tan theta minus half of g x square upon u square cos square theta. So this is the equation of trajectory. So from this equation we can conclude that this is a equation of a parabola. So the trajectory will be a parabola in a projectile motion. Now we will calculate the total t or time of flight. So in this diagram we can see that initial total displacement in y direction is 0, because at initial point it is at the 0, 0 at point O, and at final point it is at point A. So the total displacement in y direction is 0. So if we write the motion equation for y axis, we can write y is equal to and if we put the value of uy is u sin theta t minus half of g t square equal to 0. So from this equation we will get the value of t is equal to 0 or t is equal to 2u sin theta upon g. So here we will get two value of t. One is t equals to 0, that is at t equals to 0 is particle at this point, and t बराबर 2u sin theta by g when the particle reaches at destination at point A. So this t is known as the time of flight. Then the next is range. So we can see that in x direction it is moving with the velocity of ux, and total time of the projectile motion is capital T. So we can write the range as r equal to ux into t. Ux is u cos theta and t as 2u sin theta upon g. So r will be 2u cos theta sin theta upon g, and 2 sin theta cos theta we can write u square sin 2 theta upon g. So this is the distance traveled by the particle in the horizontal direction. Now the next thing is h max, or the maximum height that a particle will achieve. So for again we can see at maximum height at this point the particle will moving in this direction. So the velocity component in y direction is 0, so vy is 0. So when we using the equation v square minus u square equal to 2as, so here at this maximum height v is 0, so 0 square minus initial velocity in y direction is uy square equal to twice of a is minus g and h max. So here we get h max equal to u square by 2z, and if we put the value of uy is u square sin square theta upon 2g. So this will be the maximum height. Now we can also comment on the kinetic energy during the projectile motion. Suppose our particle will start moving from this, so up to h max the kinetic energy will decreases, and ke kinetic energy is minimum at h max, and then again kinetic energy will increase after gaining maximum height. So this is the conclusion on kinetic energy. In projectile motion, first kinetic energy is decreases because the total, if we use the energy conservation theorem here, that at h height, maximum height, the potential energy will increase and the kinetic energy will decrease. So at maximum height the kinetic energy is minimum, whereas at initial point and the final point the kinetic energy is maximum. Now we can also calculate the average velocity during the projectile. So if we calculate the average velocity, what will be the average velocity during this projectile motion? So the average velocity is displacement upon total time. So the displacement of the particle is this, and this can be written as the range, and the total time is time of flight. So if we put the value of r and t here, we can write r is u square sin 2 theta upon g, and t is 2u sin theta upon z. And if we calculate v average, then 2g से 2g कैंसिल, सॉरी यहाँ पे कैंसिल नहीं होगा. We can rewrite this as u square g and sin 2 theta 2 sin theta into cos theta upon 2u g sin theta. So 2u से 2u cancel, sin theta से sin theta cancel, and we will get v average is u cos theta. By observing this diagram, we can directly conclude that the velocity in this direction is ux. So the total distance traveled is ux into t. So this is the total distance in x direction, that is the displacement is x direction, and total time of flight is t. So we can directly return v average is ux, and that is u cos theta. That's we get in this example. Okay. Similarly, we can write the position vector at any time t. R can be written as x I cap plus y j cap. So x is uxt I cap and y is uyt minus half of gt square j cap. So this is the position vector at any time t. If we differentiate it, we can write the velocity vector. So dr by dt is velocity vector, and this will come ux I cap plus uy minus gt j cap. So this is the velocity vector. We can also calculate the distance traveled in t time. So distance is given by, as we can write from here, mod v dt is the distance traveled by the particle. V is given by this, mod of Vt will be ux square plus uy minus gt whole square under root dt from 0 to t. And the displacement can be directly written as integration of v dt, and that will come out x square plus y square. So by knowing these equations or this method, we can calculate everything. At time t, what will be the position vector, what will be the average velocity, what will be the instantaneous velocity, and the distance from the origin, total distance traveled by the particle in time t, what will be the maximum height that particle will go, and total time of flight, and the horizontal distance, also known as the range. So these are the basic equations of related to projectile motion. Now how can we use these equations? For an example, suppose the trajectory of a particle is given as y is equal to root 3x minus 2x square. So this is the trajectory of a particle who is thrown with initial velocity u at an angle theta with the horizontal. So we have to find out the initial velocity u and theta. So we have to compare these equations. We know the trajectory of projectile motion is given by y is equal to x tan theta minus half of g x square upon u square cos square theta. If we compare the given equation with this standard trajectory equation, we can see tan theta is root 3. This means theta is 60 degree. Now if we compare the second term, we will get 2 equals to half of g 1 upon u square cos square theta. So from this equation, u square cos square theta is g by 4 and u square is g by 4 into cos square theta. G is tan, 4 into cos theta is 60 degree, so cos theta is 1 by 2 whole square, and that will be 10. So u will be under root 10 meter per second. So if the standard equation or the trajectory of the path is given, then we can compare both the equations to calculate the initial velocity as well as the angle of projections. Now let us do some more example. Suppose we project two particles with u. One is 42 degree, another one is 49 degree. The question is, a particle is projected with a angle of 42 degree and same particle is projected with an angle of 49 degree, and the initial velocity of both the times are equal, and that is u. So we have to tell the range of the particle, or we have to comment on the range of the particle. Suppose in range when theta is 42 degree is R1, and range when theta is 49 degree is R2, then we have to tell that R1 equal to R2, B is R1 greater than R2, C option is R1 less than R2, or D option is none of these. So how to solve this type of question? We know the range R is given by ux into t, that is u square sine 2 theta upon g. So ranges depend upon u and theta both. So in this case R is maximum when u square upon g when theta is 45 degree, because when theta is 45 degree sine 2 theta is sine 90 degree, and that is 1, that is the maximum value. So maximum range with velocity u can be u square by z when the theta is 45 degree. In this case one angle is less than 45 degree and the another angle is more than 45 degree. So as we go from 0 to 45 degree, as theta goes from 0 to 45 degree, range will increase and maximum at 45 degree. And again 45 degree to 90 degree, the range will decrease. So it depends how close the angle is approaching, or how angle is approached towards the 45 degree. If theta approaches to 45 degree, the range will maximum. So in first case 42 degree is near to 45 degree as compared to 49 degree near to 45 degree. So in this case range will be more as compared to in this case. So the correct answer is R1 is greater than R2. The next question. From this example we can also conclude that for a angle of theta and 90 minus theta, the range is same. Now suppose H max is same for two projectile, then what will be the relation between time of flight T1 and T2? So if two particles is projected with U1 and U2 and the maximum height H max 1 and H max 2 are equal, then what is the relation between T1 and T2? So in this case we can write H max बराबर U square sin square theta upon G. So for both the projectile H max is same. This means u1 sin theta 1 बराबर u2 sin theta 2, and the time of flight t is given by 2u sin theta by z. So t is also depends on u sin theta. So u sin theta, u1 sin theta 1 equal to u2 sin theta. U sin theta is constant for both projectile, so we can conclude that t1 equal to t2. So if maximum height is same for two projectile motions, then their time of flight will also be the same. Now next, take an example. A particle is projected with a speed of 20√2 meter per second with an angle of 45 degree with the horizontal. Then find the time when the velocity makes an angle of 82 degree with the direction of initial velocity. So here a particle is projected at an angle 45 degree. So we can resolve this initial velocity along the x-axis and y-axis. So here we will get 20√2 into cos 45 is 1/√2, that is 20 meter per second. And similarly for the y direction, this will come 20 meter per second. So this is the ux, that is 20 meter per second, and this is uy. Now the question is, find the time when the velocity make an angle of 82 degree with the initial. 82 degree means 45 is this one, and the angle will be like this. So if this is 37 degree, so this type of angle it will make somewhere here, and when the particle reaches here, the velocity direction is this. So this, at this moment, the angle between the initial velocity vector and this velocity vector is 82 degree. So this angle will come 37 degree, and this component of x-axis is 20 meter per second. So we can, from this we can calculate this Vy. If we rewrite tan 37 degree is this Vy, this is Vx. So Vy by Vx बराबर tan 37 is 3/4. So Vy is 3/4 into Vx is 20. So this will come 50 meter per second. This is the Vy. We need time, at what time. So if we know the Vy, we know the Uy, we can calculate. Vy equals to Uy plus Ay into t. Vy is 15 meter per second minus 15. Uy is 20 meter per second minus 10 into t. If we solve this, we will get t equals to minus 35 upon minus 10, that is 3.5 seconds. So at t equal to 3.5 seconds, the velocity will make an angle of 82 degree with the initial velocity. So I hope you will get a good knowledge about the projectile motion. In next lecture, we will do some more examples related to projectile motion, and we will also discuss about the projectile motion in an inclined plane. So thank you for watching this video.